Alright, so I made this circuit, which is a capacitor reformer charger type deal, with the ZVS, and I'm using the PWM to vary the output, which kind of works to a degree. It's got some downsides. Obviously, the lower in voltage I go means the lower duty cycle I've got. So I'm not going to be able to push a lot of current at the lower voltages, but it kind of works itself out with the way that thing was designed. So another thing I wanted to try was this type of setup using the comparator, try to regulate the output that way. That was something that Teslaundmehr came up with. So here's an example. Here's a drawing he's got on his YouTube channel of that setup on this video. At a set point, it's going to use this transistor to pull the gates to ground on the ZVS driver. So you're basically shutting down the ZVS driver when you more or less reach a set voltage on your output. So I had to kind of play with the trimmer a little bit and added another little trimmer to fine tune that. And what I ended up with was about 50 to 300, kind of like what he's got. Depends on your transformer, of course, your voltage that you're feeding in. I decided to run it around 20 volts or so. I think that's what I've been running at. I haven't really chosen a specific input voltage. So the idea is to get about 600 volts output, which I can get with 20 volts input. So that leaves me a range of about 60 to 70 up to about 600 or so. I first built this ZVS for it and worked out right, but this one's got Amazon 260s. Choke needs to be replaced, but otherwise it would work. But just as an example, I noticed that the ramping wasn't as smooth with this one as this one. The actual output voltage ramping was fine, but let's just say I ran a load on it. For example, like this halogen, at the lowest output, say I ran it at about 60-70 volts, I'd be pulling the same current as I would if I actually cranked it all the way up. It wasn't quite working how I wanted it to. By swapping back to this familiar ZVS that works pretty rock solid, it actually did get a smooth ramping like I want. So I can ramp the voltage and I see the current go with it. So at the lower brightness, it's pulling less current. All right, so here's that halogen load on there. So we're at 20 volts input, and it's drawing about 3 amps, so it's about 60 watts right there, driving it about 66 volts, and it's not crazy bright. It's putting out a little brightness, and I can ramp that. And now it's pulling a little over 5 amps, so that's like 100 watts. About 100 watts or so, and that thing's about full bright. So drive that thing all the way up. Can't bring it all the way down. Actually, I could if I adjust the trimmer here. So I could adjust this to put out much lower voltage on the lower end, which would mean it'll put out lower voltage on the higher end. At least I believe that's what'll work. So I won't be able to get as high of an output voltage, but I'll be able to adjust that down to probably lower than that. So yeah, it's pretty cool being able to run it like that. And man, that's putting out a whole lot of heat. And obviously need a decent battery. The battery's getting drained down doing that, pushing almost 100 watts. But again, something like that, ZVS driver doesn't really mind. This circuit doesn't really mind. Transformer's kind of doing all right, so something like that's pretty handy. I wouldn't use it for running loads like this at all times, but for charging capacitors like I want, kind of seems like it'd be a good idea. So I'd say the downside with this is it sort of messes up the 0-volt switching. Feel like the switches are going to get hotter than they normally would if you were just, running an unregulated output. And that's, in my mind, I'm thinking it's because you're pretty much arbitrarily cutting the gates off at any random times to get this regulation. So using this pot right here is probably not the smoothest approach. Maybe some type of multi-turn pot would be better, more accurate. But you see I can more or less ramp up to so it's about 630, And see how slowly I can ramp that down. It's real hard. I have to take very precise movements on this pot here, so you can easily solve that by adding another one in series, a smaller value for fine tuning. So yeah, it's pretty cool. And of course, charging the capacitors, no big issue. So got this capacitor, 400 volts, 4300 microfarad hooked up, and just got this lead on to this bleeder resistor on this other charger over here. So I'm just going to bleed it off once it charges up, and that's where we're at. So you can see as I bump it up, it's going to be a pretty quick charge, and every little bit I nudge it up, you're going to see that current pop up a little bit. So that's the ZVS driver shooting up a little bit, pushing current into the ZVS driver to give that output, to charge that cap up. And it's going to go way back down because now it just needs to run the slightest little bit to put the charge into that cap to keep it at whatever it's going to be at. So you can see that voltage is actually kind of barely climbing down. And now this cap is just leaking on its own because the output voltage from the ZVS is only like 60 or so. So go ahead and bleed that like that. I'm just going to leave that bleeder on and adjust my output now with the bleeder. So I don't really mind that one amp or so. So I'm just going to do it in real time. And once I get up to about 270 or so, that's when that bleeder starts to become a problem, right? So I wouldn't want that on there, but I'll go ahead and bleed that all the way down, then charge it back up to about 400. Got the cap drained down. It's sitting at about a volt or something like that. So I'm going to disconnect the cap from the output, cut it on. So that's our bottom end, and I'm just going to crank it to a desired voltage. So let's just say I want to put about let's just put 350, about 350 in this cap. That'll be alright. So cut that back off, leave it at there, put the cap back on, and now when I cut this on, you should see it charged to 350. So when I cut it on, you're going to see the current spike up as the ZVS works fairly hard to get that charge up. Then it's going to sit there and the current's going to go back down. Right, so you see how that works, and it's about expected. So you can see to maintain that voltage, ZVS has to work a little bit harder than at the much lower voltages. So it is about 16 volts, about half an amp, so 8 watts, something like that. It's still not too bad though. Cut that off, we'll let it drain back down, bleed that back down. So anyway, that's pretty much the idea, to where you get a nice regulated output, set a specific output voltage, charge a cap up with it. I won't have to wait. Now, to actually get it to regulate the charge rate, all I can really think to do is use CC control, so limiting the current, which more or less is going to give you a fine tune on the voltage. That's about the only way I can think of that would really work, but it does seem to work, so it's pretty cool. So with this particular setup at 20 volts, I could bring a series of 2 caps, up to like 650 or so. All depends on the transformer. I might rewind that, but again, that seems to work pretty cool. So yeah, nice little idea by Teslaundmehr. It actually seems to work out fairly well, so long as you've got some pretty solid ZVS driver and whatnot. But again, if I'm just charging caps like that on a type of system like this, which I'll probably end up making it so the output is going to have an inline milliamp meter, then it will be a pretty decent leakage tester that'll serve the function, except once again it'll be battery powered, and I won't actually have to wait for that charge to happen. So I could actually kind of go between both devices, or maybe combine both into one. Yeah, it's a pretty cool feature.